Solving one-step equations. So we're going to solve one-step equations today using inverse operations. So whenever we're asked to solve an equation, we will always have the same goal. The objective is to isolate the variable. That means get it by itself. So it needs to be all by itself on one side of the equal sign, all alone. The tool that we use to do that is, like we said in the target, inverse operations. If we use inverse operations, then things cancel out and we can get that variable by itself. And then the golden rule, anytime we're solving equations, is to keep things balanced. So whatever we do to one side, we have to do to the other side. Do the exact same thing to both sides. That's the only way that it actually stays equal, right? If I add 2 on this side, I have to add 2 on this side so that it stays equal, okay? So we're going to follow those kind of basic rules as we go through today. Let's just think about what inverse operations are. What is the inverse of adding 5? Well, kind of like the opposite, but we call them inverse operations, would be to subtract 5. Or the inverse of subtracting 8 would be to add 8, right? And the point is, if I do both of those things at the same time, subtract 8 and then add 8, they cancel out, right? Or if I add 5 and subtract 5, they cancel out. So that's how using inverse operations cancel things out. The inverse of multiplying by -3 would be to divide by -3. And if I did both of those, they cancel out. Divide by -6, the inverse would be to multiply by -6. Multiplying by 4, the inverse would be to divide by 4. Okay, so now that we know what inverse operations are, when we solve equations, we use PEMDAS. They can go on the lines there. Backwards. We do it in reverse order. So now we're going to work through it this way. So I've rearranged the letters S-A-D-M-E-P. S-A-D-M-E-P. So I made this up, SADMAP. If you hear me say SADMAP, that just means remember we've got to work backwards as we cancel things out. So this will come into play more when we look at two-step equations. Today we're only going to have one step to cancel out, so that won't matter as much today. Let's turn the page. There are some steps to showing our work. Whenever we are solving equations, this is kind of what we want to see as your work on the paper. Draw a line down the equal sign. So starting with the equal sign in the middle, whatever your equation is, draw a line down that equal sign. Show your work on both sides. Whatever work you do here, make sure you also show it on the other side. Actually cross out. If you do inverse operations to cancel things out, cross it out so you know that you have canceled that. Work down. We're only going to work down, not across. So in elementary school, sometimes we had equals, and we worked our way across the problem this way. Now we are only going to work down, straight down. Rewrite the problem after every step. So we'll do one step at a time. Today we probably only have one step, but when they get a little bit more complicated, one step at a time and then rewrite it. Check your answer by plugging it back in. Check your answer by plugging what you got back in to make sure it works. So we'll do that in all of our examples today. And then when you're done and you've checked it, circle your answer. Okay, so here's what we're going to do. I'll do these 4 together, and then you can practice. All right, first thing, I want to find my variable. Since we said the goal was to isolate the variable, get that variable by itself, I'm trying to get that x all alone. So draw your line down the equal sign. There's my variable. Right now, the x is being multiplied by 5. So I want to cancel that 5 out. Well, the inverse of multiplying by 5 is to divide by 5. Whatever I do on one side, I have to do on the other side. Actually cross out what cancels and rewrite, bring everything down. So all I have left here is x, and then I'm actually going to do -45 divided by 5 is -9. Okay, Well, I'm not done until I actually take that and plug it back in and check. So I'm going to put that negative 9 back in here, plug it back in. 5 times negative 9 is negative 45. So I get this number back again. That means I've checked it in my head or my calculator, and that is correct. Okay? Let's try another one. Number 2. Draw your line down the equal sign. Find your variable. This is what we're trying to get by itself. So we need to cancel out this dividing by 8. And I use inverse operations to cancel things out. So the inverse of dividing by 8 is to multiply by 8. Whatever you do on one side, you have to do on the other side. Actually cross out what cancels. Multiplying by 8 and dividing by 8 cancel out. Notice I've kind of put it up top here, so you see that I would have 8 over 8, and that just makes 1, so it cancels out, and bring it down. All I have left over here is y, and negative 7 times 8, negative 56. So I still have to plug it back in and check it. If I take this negative 56 and put it in for y, negative 56 divided by 8 does give me that negative 7. So I've checked it, double checked it, and I know it's right. Check. All right, let's keep going. Draw the line down the equal sign. Highlight the variable if it helps. This is what I'm trying to get by itself, so I want to end up with n by itself over here. So I have to get rid of minus 13. Well, the inverse of subtracting 13 would be to add 13. Whatever I do to one side, I have to do to the other side. Minus 13 plus 13, or you could also think of this as negative 13, positive 13, cancels out, and bring everything down. N equals, and then I just have to work this out. 65 plus 13, 78. Okay, let's plug that back in and check. If I put that 78 in here for n, 78 minus 13, yeah, that would give me 65. So I've checked it, and it works. It might seem silly or simple now to have to plug this back in to check it, but when we get to more complicated equations, you'll be able to catch some mistakes that way if you really take the time to plug it back in and make sure it works. All right, number 4. Draw your line down the equal sign. Highlight your variable. I'm trying to get this p by itself, which means I have to cancel out plus 3. Well, the inverse operation of plus 3 would be minus 3. Whatever I do on one side, I have to do on the other side. Plus 3 and minus 3 cancel out, so cross them out and bring everything down. I have p there, and 18 minus 3 is 15. Plug it back in. If I put 15 in here, 15 plus 3 does give me 18. So I checked it, and it works. Okay, so let's just get started on these ones, and then we'll go over them in a second. But go ahead and draw the line down the equal sign. Find your variable. You could circle it, you could highlight it. Draw your line down the equal sign. Find your variable. Draw your line down the equal sign. Find your variable. Okay? So in each of these, we've got it set up, ready to go. You're going to do the inverse operation to cancel this out so that you end up with p by itself. Do the inverse operation to cancel this out so you end up with w by itself. Do the inverse operation to cancel this out so you end up with x by itself. Go ahead and pause and hit play when you're ready to check. Okay, so if I'm looking at number 1, I would add 5 to both sides. I got p equals 3. And yes, if I put 3 back in here, 3 minus 5 is negative 2. Here we have some decimals. So this brings us back to chapter 2 where we would have to work this out. Maybe you go over to the side and do 13.2 minus 10.4 and you get your answer, negative 2.8. Remember to cross out what cancels. And some fractions. Lucky these already have common denominators. So negative 1 plus 5 gave me 4, and 4/6, remember, could be simplified to 2/3. So fractions, decimals, simplifying, All the rules we already learned in chapter 1 for positive and negative numbers, that all still applies. Let's see what we have on the next page. Okay, so there is one of each operation. I see multiplication, division, adding, and subtracting. So just do the inverse operation quick and get the answer. Get the variable by itself. So here I want to get k by itself, get c by itself, get x, and get j. Pause now and work just those 4 out. Hit play when you're ready to check all 4. All right, checking this first one, I would multiply by -4 on both sides. I would show it up here, but my paper is stapled together, so it's hard to write up there. But I get k equals -28. Here I would divide by 5 on both sides. I do want to point out something really important. From here on out, we're going to show division with a bar like this. So that kind of big fraction bar means to divide. You're not going to see this very often anymore in 7th grade. Kind of switch over your brain to thinking about dividing like a giant fraction. So a 5 on top, 5 on the bottom, those cancel out, and this is -30 divided by 5. Here's my next one. If I get x by itself, I need to do +8 on both sides. And here I would be doing -12 - 12. -4 and -12 combine to make that bigger negative. So that is video 4, one-step equations.